Okay, so I'll send out another URL. It won't send out another URL. Okay, I sent out a new live stream URL. This should work better. Okay, so we have, so remember the structure for each document is each document represents a color, and we maybe weren't explicit about this yesterday, but we don't want multiple documents for a given actual color, right? When we load a document, we want ideally a particular wavelength of light or a particular dye. I think a particular RGB color point at least, and we want to collect all the data that people have about that color point in that document. So if people have comments collection, every name that anyone has given to it, we want to be associated with that. And that's going to help us sort of find and correlate these different color libraries and be able to say, like, hey, you like this palette. Here are some other palettes that are similar. So how do we do that? How do we guarantee the uniqueness of, though we're going to like encounter duplicates? There's a couple of approaches, actually. Any thoughts?
Group them by RGB and make a list of the names that have the same exact RGB.
Right, so we can scan this list. We can, using Lodash or just ourselves, we can find all the names for a given color and then just create a document for each color. And that's a totally legit way of doing it. That might actually even be better than the way I'm about to suggest. Another thing we could do is decide that just for the seeded colors, or maybe even not just for the seeded colors, Firebase gives us these auto-generated document IDs, but we don't have to use those. We can actually create a document with any ID we want. Like, here's a document not following our schema whose ID is this garbage that I just typed. Here's another one named Alice. And because we can pick the ID, we could pick the ID to be the thing that is actually the key for us, which we're going to say is the RGB color triple, or some string representation of it, like, for example, the hex representation. So if we had, 255, 0, 255, we might store that in the document FF0FF. And then if we set data in our document in such a way so as to only update the data, document will collect all of the seed data. And that's my theory, at least. I actually haven't written this yet, so let's do that. Okay, so let me fix that. I got a little bit excited about having that alias and forgot that in Node we don't. Okay, so here are my colors. I'm going to go through each of them. It's not very surprising. So it's arguable whether this is like the best way of doing this, but you can basically like destructure inside of a destructuring expression. So color equals entry.color. But instead of doing this, we can ask JavaScript to basically write that code for us by using the curly brackets on the left-hand side of an assignment, the destructuring curlies. And then we can do it again inside. So we can say from color, you should pluck red, green, and blue.
Couldn't you just reference it though, color.r?
Yeah, but I'm gonna say like RGB here. So I think it's a win to not have to be. It's a win if everything's working. Here's a whole bunch of RGB values. Cool. I wonder if IDs can start with a number. They can. Great. I should delete these documents that don't have anything in them. Because right now we've got these squares that aren't actually colors. I don't even know why they have a background color at all. Okay, so now we have an ID for our document, so we can go ahead and create a document of that ID, or update one if it exists. So let's first get a reference to our collection. We can do that out here. Here, let's actually call this seed data something like seed dot set. This will let me set data on the document. And set takes a bunch of cool things. I can, so first of all, I'll give it red, which is R. Red is R, green is G, blue is B. And then I want to set this name in names, which I can actually do, I believe, by saying name is true. Your JavaScript thing, it's a computed property. So it says JavaScript properties, or properties of JavaScript objects can be take the computed value of this expression and use it as the key. So you can do anything in here. I can do 2 plus 2. I can do like dot to uppercase. Or in this case, I can use, I'm actually not totally sure, but I'm pretty sure it will create it. And then if I say merge true at the end of all this, the provided data can be merged into an existing document. Otherwise, it'll overwrite whatever's there. Okay. This thing returns to we'll get some feedback here. Oops. Backticks, man. As we're seeding, oh, it's working. It's working, but we're not getting the names, which is kind of troubling.
Some of them might be named name or names. Like that. In the original code, it was names.
This is very pretty, though. I'm really appreciating this. There might actually be so many things in this document that this page is going to get a little bit.
There's 2018.
Oh, that should be okay, right? It'll be a big page, but not, you know, the end of the world. Oh no, my computer is pretty. It's starting to take off. Okay, let's look at what's happening in the database here. Okay, so we've got a bunch of documents. This is about what we'd expect. Names.286c, true. Oh, so this did not do the thing I wanted. I wanted this to update a deep field within the object, and it didn't. I'm so sad about that. Actually, that, I think we can. Here, let's try this.
When
Let's
you
just
don't specify the type, right? Because when you do it manually through the GUI, you have to specify the type.
yeah, you don't actually have to in the
it
console
infer?
because, well, because it knows, JavaScript knows the type of the thing.
Oh,
At least insofar as whether it's a string or a number or an object. That's about the level of typing JavaScript has. Okay, well, let's delete this whole collection and try it again. This time, yeah, so what went wrong here? This is something that Firebase supports when you update. You update a deep key in this way. And maybe we just have to do a set and then an update. Or maybe we can say something like names, name true. So I'm going to try this now. And my theory here is that because we're saying merge, this will merge merge deep properties. We should be able to, let's see, 255G. Let's see. Really? It can't find 255 anywhere? That seems so unlikely. Zero. Okay, so we're gonna try this. We're gonna look at black to see if this works, because black, there's actually multiple instances of it being called black, but it's also called gray 0. Charcoal, did I see? No, charcoal gray is a different color. But anyway, that's a good example of like something with multiple names. So we'll try that and then see if they show up here. Okay, seeding again. Oh, it's still working because I still need to delete things. I'm surprised there's no faster, like, just delete the whole collection. Maybe that's a good thing.
maybe that is good.
Yeah. Yeah.
Oh wait, can we change, if we're like testing, can we just change the name of the document maybe? So like colors to or something.
Yeah.
Yeah, that was
And then eventually you get the right thing. Another thing you can do is say like I equals, you can like not seed all of them. And in fact, maybe we should do that. Let's, I'm gonna create a, like, so name, oh god. Okay, so name, fuchsia, color, G, B, name, violet, same thing. Purple. And then what was the other thing we did? We had like a cyan, which was this bright teal. How about just a blue? Gosh, that's blue. And then we'll do like a sky blue. Which, I don't know, what do you think would be sky blue? Like 100, 100, 255? Okay, so that should be a much easier colors. Are we done deleting? Oh, wow. Yeah, and let's just tell our app to look at the colors 2 collection. This is pretty cool. Watch it delete everything. Okay, but there's nothing in colors 2 right now, so this will just be empty until we seed it. Whew. And now nothing is happening, which is very concerning. Oh, that's not helping because I have to export it. Module set exports. There we go. Oh, so that worked. That did exactly what we wanted. And if we look at this, okay, great. So this did exactly what we wanted. And it worked to just specify this as an object and merge true, merge what was there. So that's great. Okay, let's point this back at our collection. Now I'm like, this is a lot of data we're seeding. Maybe we'll have to deal with pagination faster than we thought. Let's go back to the previous collection. Okay, so questions about this before we move on. So what we ended up doing. Okay, let's do another thing and put in the generated values that we're going to need in order to like sort this by hue. For that, we'll want to, oh, interesting. Let's look at the database. It looks like something strange is happening. Are we still seeding into colors too? No. So this error, if you see it, what it usually means, object found with keys HSV. Oh, that's not good. So this means that we've written something in the wrong form in our database. So let's go see what that is. Oh yeah. Oops. Lightness nan, saturation nan. Okay, so I did something wrong. What was the thing I did wrong? Oh yeah. I can't just compose these two functions because this one expects H, S, and L. So kind of we have to do this manually. HSV dot H, HSV dot S, HSV dot V, and then okay. That should fix it. That looks better. And then this looks correct. So now, these kind of already look sorted by hue, don't they? But now we can sort them by hue if we want, which will be more exciting on a bigger data set. So let's actually go back to seeding all the colors, or let's seed like 1,000 of these colors. How about that? In of 1,000 and seed.length, and we'll pull in all our colors. And then rerun this. Seed a whole bunch of things. They still kind of look sorted by hue, don't they? But it's not, it's like a little bit patchwork. So 100 pixels by 100. And then, should it be reloading at some point? And then we can make we can say order by, and I think we can just say order by hue. And so that'll ask Firebase to return everything. Oh, maybe that. But turn it into a rainbow. There we go. I liked it more when they were bigger. And I think we can actually order it by multiple things. So you could order it by hue and saturation in order to get sort of a more subtle gradient effect. This, for example, it's a dark red, right? But its hue is technically 0. Because, or rather, all of these grays are technically like red with no saturation, which makes it look a little funny. But that's about as much work as I want to put into organizing colors in a social justice fellowship. Yeah.
How do you update the data in our database? Do you need to just stop updating instead of the set if you have the dog?
Yeah, so you can actually use set if you want.
You just reset it.
Well, you can, if you include merge true, then it'll merge the values in. So it won't overwrite anything that's already there that you haven't specified. You can do. If you want to conditionally change what's there, you're like, if something is true in the database, then change something else in the database. You want to use a transaction. Because you want, if that thing has changed, then you want your write to not happen, right? Mm-hmm. Is that still legible? Yeah. Oh, that's in the view over here. I can, no, can I do this? No, I can't. So that's right here. Just specify a key to order by. Okay, so we can go several directions with this. One thing we could do is do searching, so you can at least find all the colors that have a given name. We could do, or we could talk about user authentication and adding like not collecting user data, but like letting people add their own names for colors, for example, and showing all the colors that you've tagged or named. Which of those avenues sounds more interesting or / applicable and useful? The last one. Okay, so let's do that. So, in order to have users, you need some like you need a you don't necessarily need like a login and sign in. Like you don't need to identify them in the sense that you know their email or know anything about them, but you do need some sort of ID so that you can say like, okay, this same person who is identified by this number, because we are all numbers in this world, did all these things. Like they tagged all these things as their favorite, or they like added them to a palette, that sort of thing. So Firebase gives us a way to do this without collecting information about the user, so without like collecting an email or password. Is everyone familiar with cookies? Sort of vaguely. Let's see. Do I have? I have some slides on this that I'm just gonna pick up. Talk about security, and in particular when we talk about like authentication, there's like the three big A's. One is authentication, which is like figuring out who you are. That is usually that's where you have like an email, a password, and maybe some second factor of authentication that proves that you are the person who created this account, or at least that you know the same secret that that person did. Authorization is when we look up information about you to see if you're or as sent. And then there's accounting or auditing, which is arguably the most important part of the security triad, where we want to be able to track who has done what in order to identify bad actors. So this talks who you say you are, and how do we keep track of who you are at all? The typical way this is done, of course, is you create a password, and that's stored in your stored in a database. If you just store the password in the database in plain text, you kind of have this problem, right? Because the moment your database leaks, and your database is going to leak, you have to assume that at some point everything you've stored is going to end up on the front page of Slashdot or the front page of Reddit. then you've revealed all your users' passwords, which is kind of bad, right? Because you don't want, now everyone can log in as them on your site. But it's actually worse than that because people reuse passwords. So now people can log in as them on like every site, or can log into these people's email addresses, which you are also storing alongside their passwords, most likely. And so the way in the same input, and then you can compare when someone goes to log in, you compare the hashed version of the password they gave you with what's in their database, or what's in your database, rather than comparing the raw text of the passwords. And this prevents significant, if and when your database leaks, you have not revealed the actual substance of people's passwords. There's a bit more to it, yeah. Time for that right now, but I can send out resources on how to implement something like that. There are modules all the way down, depending on how deeply you want to implement it. Okay, so the problem we face on most sites is like, what if we want to store some sort of information about even just the context of what you're doing right now? So like in this app that we're playing with, say I can like pick things and like be adding them to a palette. Where do I store that? Another example is like a shopping cart. If I'm like adding things to my shopping cart, where does that go? Or if I'm like marking, if I'm marking information on a map, like where does that go? And the answer can be into your database, right? And probably for a lot of these use cases is eventually into the database. But we still have the problem of like identifying you on subsequent requests, right? Like you have logged in, which means there's some fact about you that's now true in the session, in like your browsing session. But HTTP is a stateless protocol, right? Every request, the server does not remember anything about you from request to request. That might not necessarily be true. Servers like can try to, but there's no like identifying marker that's sent back. So what are some ideas? How do we like basically implement persistence on top of a protocol that doesn't necessarily have any?
Send it each time.
Yeah, so you can send it each time, which gets tedious if those are login credentials. But you could extend the protocol, perhaps, to send something each time. Yeah, you had a comment, I think?
I'm not sure.
Yeah, so some other ideas that don't work as well are like script variables, or you can save something in the database, but the question is like, how do you get it? How do you know which thing to get back out of the database on the next request? Right, these don't persist across navigation. How do I, right, if I have to send my username every request, that's not very helpful. So the answer that was written into HTTP many years ago is cookie, which many people are terrified of. All a cookie actually is a piece of text that's given by the server to the client, and the client remembers it, and on subsequent requests to that same server, it sends the cookie back, picked out by it. If I have like an ad loaded in an iframe, that can set a cookie because like the client requested something, it requested this ad, and the server went back and was like, okay, set this cookie, and now in any ad from that same network, that cookie gets sent back, which is, that's why every time you search for anything online, like ads for that thing follow you for days, right? It's even if you decided you don't want it, which is also apparently one of the most effective advertising tactics there are, because like once you've searched for something, we kind of know that you want it. So the header, this is kind of what the header looks like. You can see it on the bottom. That's what's sent from the client to the server. The server sends a set cookie header first to the client. And it looks like this. So the client sends a request over the internet to the server. And the server sends a response. So that's sort of a uncookified request response cycle. Almost no HTTP requests work that way anymore because almost every server you visit sets a cookie, if only to manage like abuse prevention, right? It can be helpful to be like, oh, this like same browser is like requesting millions of pages. I'm going to rate limit them or something. There's other ways of doing that, of course, but there's also a strong tendency among service providers to sort of want to track things. And so most sites, even sites that don't necessarily need it, will set a cookie of some kind. And that looks like this. So the client sends a request to the server. The server, when it sends the response in a set cookie header, and now the client stores that internally. How long the client stores the cookie for is, it's specified in the cookie, but ultimately up to the client, right? You can go and clear all your cookies. You can go and tell your browser to just like not remember them, which will really screw up the internet for you. But maybe that's fine. Maybe like you can take a principled stand against storing that data. But on subsequent requests in the default mode of operation, the client will include that cookie, which lets us it lets the server sort of track state information for the session. Yeah.
So is that working with different servers? So if the client keep browsing on different websites and different servers, is that changing?
So a cookie is bound to a domain. So it'll only include a cookie that was set by google.com on request to google.com, for example. And you can even specify like what paths the cookie should be delivered to. In general, cookies are set on like the root of like facebook.com or google.com, whatever the site is, and they're delivered in all requests to that site. And then the server can do something with it, and thereby serve the request differently. So this means that we don't have to authenticate for every request, which is nice. It lets us track state information, which is, you know, a mixed bag. It's like very useful, and also if the state information is like what things you want, it helps out advertisers. And the server can use cookies to implement sessions. So when you get a request from a new client, you go and create a session with a new ID. You make this blob of JSON data that represents all of the session information, like everything in your shopping cart. Sign it cryptographically so that you can trust that you, the server, did actually set up this data. The client isn't just sending you a cookie. And then include it all in include it just in the raw cookie to be returned back to you. And that's kind of nice because it means you don't need to hit the database to access session data. Yeah, so this is the general flow. As the server will serialize the session to the cookie, back from the cookie. I might flip through a few of these. 1 second. No, let's look at this actually. We're going to add a set cookie header to the response, which will include whatever information we want from the session, in this case the user ID. We send this response back to the client. It reads that set cookie header and stores it into the cookie store for your domain. And then on subsequent requests, it attaches that cookie again, which lets us go and get information back from the session store. So this middleware will go and look up the session, find it. So in Firebase, not loaded yet. So for us, it's signed in, and that's just always true. But then the auth data loads, and we get a currently logged. Let's just